Now we come to filtering vectors. So filtering with the subset function. So you can filter with subset. You can actually use a filter as a, there is a separate function filter also, and then you have direct handling of the vector also. Now we'll go for the subset function. So x allocation C 6 comma 1 sequence 3 comma na comma 12. So we are just basically preparing a vector. So this is the vector element 6 1 2 3 na 12. Now you are saying x box bracket x greater than 5. So you're basically doing a subsetting over here. You're telling give me all those numbers which are greater than 5, and you wrap that, and outside that you say x. So what is happening internally is it's checking true or false whether that vector element is greater than or less than 5. So the first element 6 is obviously greater than 5, so it returns true. The second one returns false, the third one returns false, the fourth one returns false. Now for an NA, which is a not applicable, it is not getting trapped, so that will also be returned. So that is why we say that you need to handle missing values. And then the 12 is also returned as true. And for all those wherein the logical operator comes as true, when you wrap that and extract that, so x box bracket, so you have all these true false inside there. So for wherever there is a true, it will return you that value. So obviously you will get 6 na 12. So subset function handles na, whereas the basic operator wherein you mention x greater than 5 will not operate. This is the advantage of using a dedicated function. So when you say subset x comma x greater than 5, it will return only those values which are numerically greater than 5, which was not handled by the previous method of subsetting. The selection function, which this also comes in handy when you want to do something with the position within a vector, right? So if you say z, you're creating a vector z allocation sign z allocation C, that is concatenate 6 comma 5 comma minus 3 comma 7, and this is the vector you have created. And when you say which z multiplied by z greater than 9, so basically it is going to do a multiplication of the vector and just trying to check whether it's greater than 9. So which are the vector, so it's basically giving you the location, not the values, because you're asking for the locations. So the first element 6 multiplied by 6 36 is less than 9 or greater than 9. It's greater than 9, so it's a true. 5 by 5 25 is greater than 9, that is 2. The second location is also returning you true. Minus 3 into minus 3 is 9, which is actually equal to 9, so it is false, so that's not the location. And the fourth location 49 is greater than 9, so that's a true. So it says that the first, second and the fourth location actually follows this rule. That's how you can see this. However, the expression z multiplied by z greater than 8 will be a bit different. So it is saying true, true, false, true. That's how you will have to evaluate. R also includes a vectorized version, the if else function. The form is if else bracket b comma u comma v, where b is a boolean vector and u and v are vectors. The return value is itself a vector. Element I is ui if bi is true. For example, if you create a vector x allocation sign 1 colon 10 and you say if else x, right, you use the % sign 3 is equal to 0, so you're basically checking with the mod operator, right? And if it is actually coming out to be 0, then you are flagging it with a y, or else you are flagging it with an n, right? And this if else statement is exclusively used for most of your operations, right? But the point is, if you use an if else, whatever is going to be created will always be a vector. So when you're working with data frames and if you're using an if else, you have to make sure that if you are getting something as a vector, when you want to purge it back, you have to make sure that it is going back as a data frame. Similarly, you have nested if else, right? So h is a vector, concatenation function, a, f, f, m, 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 f, all separated by commas. The commas are compulsory, right? And that's where you get this vector created. If you use an if else, you can check whether h is equal to m. So you're basically doing a cross check. Comma 1, if else g double equal to f, comma 2, comma 3. So the first parameter is for true. The nested parameter is that if something goes wrong, if this is not applicable, what else you want to do. That's what is coming up in this.